This is third part of alpha particle scattering experiment, and first thing that we have to discuss is that why alpha particles were good for the experiment. Because if you have an individual positive charge or you have clusters of positive charges, the result would be different. From individual positive charge, the alpha particle will not have any deflection. It will pass straight. However, if you have clusters of positive charges, then the alpha particle will have a deflection like this. So when you have clusters of positive charges, alpha particles will deflect, while from a single individual positive charge, alpha particle will not undergo any deflection. Now, the results of the experiment and what were the conclusions. First, let's discuss the predictions. Predictions before the experiment. Prediction before the experiment. Before the experiment, before the experiment, it was the non Big model which was before the experiment, it was plum pudding model which was valid, so they believed that the positive charges are scattered. They believe that the positive charges are scattered throughout the structure of the matter. So before the experiment, the model of the bed that was valid was plum pudding model. And if that model is correct, according to the plum pudding model, all the alpha particles must have passed straight. So if the plum pudding model was valid, then all the alpha particles must have passed straight. Ji beta. Yes, beta. Guria beta? हाँ बेटा मेरी बेटी सो जाओ आप. अच्छा, excuse me students. All the alpha particles must have passed straight if the plum pudding model was correct. What was the plum pudding model is, so this was the hypothesis, which states that the positive charge is scattered. According to the hypothesis, the positive charge is scattered throughout the structure of the matter, which leads to all the alpha particles passing, which leads to all the alpha particles passing straight, which leads to all the alpha particles passing straight on deviation. So, according to this model, all the alpha particles must pass straight. However, the other null hypothesis would be the null hypothesis would be, according to null hypothesis, the alpha particles may, the alpha particle may deflect if there are clusters of positive charges. The alpha particles may deflect if there are clusters of positive charges, and there are two possibilities. The clusters may be huge or they may be small. So, for example, if there are huge clusters of positive charges, so one situation is, let's suppose if there are huge clusters of positive charges, one possibility is huge clusters of positive charges, not scattered positive charge, and the other possibility is if the positive charges are in small clusters. If the positive charges are in very small clusters, if they are concentrated in small regions, very small regions, they're like this. So positive charges could have big clusters or they could have small clusters. If positive charges have big clusters, then the path of alpha particles would be, this will deflect, this will deflect, this will also deflect, this will, this may deflect less. These are, all of them are the alpha particles. They are their paths. This will deflect upwards. This will deflect head on. This will deflect downwards. This may pass straight. This would have been result with huge clusters of positive charges. With small clusters of positive charges, the result would be, small clusters of charges. So small clusters of positive charges are relatively this type. Now, if we define these deflections, then we should know three things. The alpha particle, when it is passed through a gold leaf, there are three paths which are to be understood. First path that is to be understood is that is undeviated. This path is alpha particle passing undeviated. Second path could be it's possible that the alpha particle is deviated through angles which are less than 90s. Or it's possible that the alpha particles are deflected through angles which are more than 90 degrees. Let's suppose this angle is, for example, maybe it is 130 degrees or something. So passing undeviated, deflected at angles less than 90 degrees, and then you have deflected at angles greater than 90 degrees. So deflection at angles less than 90 and deflection at angles greater than 90. These three possibilities are there. Alpha particles may pass straight undeviated, or they may deflect at angles which are less than 90 degrees, or they may deflect at angles which are greater than 90 degrees. Three possibilities are here, and we listed all the possibilities. Now you see, what was the actual result? The actual result of this experiment was what happened was that if this was the if this was the gold leaf, then the expected results are the alpha particles may most of the alpha particles may pass straight undeviated. Most of the alpha particles may pass straight undeviated. However, a very few alpha particles may have reflections at angles. There may be some alpha particles which have reflections, like this alpha particles may have reflections at angles which are greater than. So this is reflection at angle greater than reflection at angle greater than 90. This is one case, and it's possible that the reflection is at an angle which is it's possible to get a reflection which is at an angle that is less than 90 degrees. Let's suppose 45 degrees. So a reflection at 45 degrees or a reflection at an angle greater than 90 degrees may occur. And this is broadly, and these are the alpha particles which are shown. So these are the actual results. Now, what these results show, however, this type of particles which have reflections at angles less than 90 were a bit more than particles which have reflections at angles more than 90. Now we need to like write the observations. The observations were, first of all, most of the alpha particles passed straight. Most of the alpha particles passed straight. This is the first thing. A few alpha particles were reflected. A few alpha particles were reflected at ये ले लो बेटा ये ले लो. A few alpha particles were पूरी ले लो ये. A few alpha particles were deflected at angles less than 90, and a very few alpha particles were deflected at angles greater than 90 degrees. However, most of the particles, as you know, they were passed straight. Now, what these conclusions represent? So, what these observations represent basically? We will write conclusions. Conclusion. The first conclusion is, since most of the alpha particles passed straight, which shows that which shows that since most of the alpha particles are straight, which shows that the most part which shows that the most part of the matter is empty spaces. A few reflections, a few reflections show that most of the alpha particles pass straight, which shows that the most part of the matter is empty spaces. A few reflections occurred, which show that a few reflections show that sorry, basically we should say that reflections, not few reflections. Reflections occurred, reflections occurred, which reflections occurred, which show that there are shows that there are some clusters of positive charges. Yet the yet the clusters are of yet the clusters are of small size. There are clusters of positive charges, yet the clusters are of small size, as there are very few reflections, very few reflections at angles greater than 90 degrees. And since the clusters are small, since the clusters are small in size, so they have very high density. Since the clusters are of very small size, so they have very high density. That is something that we must know. These clusters later on were called nucleus. Later on, these clusters were called nucleus. So later on, these clusters were called nucleus. They were clusters of positive charges. They have high density and all these things. There. Now, there are two things which you must remember: what was expected and what is expectation. what they actually achieve. What they actually achieve. Their expectation was all the alpha particles, must pass straight, all the alpha particles must pass straight, undeviated, according to the Lam pudding model. Basically, according to the model in which the positive charge is scattered throughout the structure, the alpha particles must not deviate at all, but they must pass straight undeviated. However, what they actually achieved was there were there were there were few detections of alpha particles. However, most of them passed straight undeviated. So basically what happened was there were few sections of alpha particles while most of them passed straight undeviated. And the deflections the reflections which were at angles greater than 90 degrees were very few, which showed that reflections which were at angles greater than 90 were very few. They showed that the clusters of positive charges are very small and highly dense. We are done with alpha particle scattering experiment. The next part would be about particle physics. Dear students, in the next lesson, we'll cover the particle physics parts.